Alright, hello and good morning and welcome back to Carroll Custom Cadillac. Unfortunately, I have to make another video to clear up some deliberate deception and a misconception on the part of Mr. Weeby from Northstar Performance. And I will start out by sharing a post on a thread on the Cadillac forums, a place us real techs never visit anymore. But I do get a lot of people calling me and telling me about these things that have been derogatorily added to the forum. So what we have here is I got a client overseas that had his Cadillac done by a mechanic shop in Poland. And of course he's used our custom state-of-the-art superior head studs compared to no other product. There is no other product on the market today for the Northstar besides ours as far as head studs are concerned. There is somebody who's making something that's not made for it. But here's the post that we're going to work on today. The car in question here had a small overheating issue after the head job. So immediately, like wolves after sheep, we got this guy jumping on the very moment he can to try to raise an issue about our superior product. And so as soon as he thought that maybe it had something to do with it, he jumped in to derogatorily say something here. So I'm going to read the post to you, and then we're going to move on and show you the difference and show you that this is an untrue fact, and then we're going to properly show you the difference between freehand and a self-guiding system, and then an absolutely unnecessary piece of equipment, a couple $100 worth that you do not need. So here it is. So after a few postings about the vehicle, we get one here from Mr. Weeby himself. He jumps in and says, Gino 9, never drill and tap an engine block freehand. There is a reason I sell a fixture plate with my kits. The slightest alignment issues, and I love this part because take note, a little bit of technical advice going on here. The slightest alignment issues shift the stresses in the block. Take it from someone who has experience. Experience? Doesn't matter what kind of threading tap you have, bottoming, taper, spiral flute, etc. I know taps. You will never thread a hole completely straight without using a guide of some sort. Anyone who wants to argue this point, come to my shop. We will do some experimenting on this. Now I love this part. Now after all that, it gets real kind to my client. I hope all goes well, that you can get that overheating issue sorted out. Wishing you all the best, Jake. So after jumping in and making a fool out of himself there, my client replies, oh, they used their own alignment jig. So they didn't drill freehand. Oh my God, man. I tell you, I hear some of the stupidest crap, and I get people calling me all the time. They go, I can't believe the trash that I hear that guy saying, man. It's just constant. They always ask me, how come you don't comment on there? I ain't got no reason to comment on there. I'm not competing with this guy. But when something like this comes up and it's a misconception and people's trying to make you think that we're freehanding, that's correct. That's wrong. Now in this post, it talked about you will never get the thread, you will never thread a hole completely straight without using some sort of guide, right? Or some guide. Well, we're going to explain something here between my guiding system and the one that this guy has you thinking is a piece of security and give you peace of mind. So let's see if I can get this right up here to you. So this is the original plate, or one of them anyway. Now, it's been changed recently to this newfangled thing that looks sort of like this. It's the same thing. It just don't have this extra material. There is no difference. It's a useless, wasted time. It's useless waste of time and a useless waste of metal, and it's an unnecessary cost, and it's something you absolutely do not want to use and you don't need. So what I got here is I got the plate, and I've got this bottom bit out for a reason, this tap. And the reason I have this tap out here is this a 5/8 11, and it has a full body set of threads that go from the top to the bottom. The reason I'm going to use this is so that you know it doesn't have a taper to it, and it's not a plug tap. So when I put this inside this tapping hole on this plate, you're going to see what happens after about the 15th hole. And the more you put this in and out, each time that you install this tap into this hole, you make this hole a little bit bigger. So in the very, very beginning, it might have been a little bit tight, but by the time you get to the 20th hole, I'm going to ask you, I'm going to show this to you, and I'm going to ask you, do you believe that this plate is keeping your hole 100% vertically straight? So when I read in there that about the stresses of the block and the alignment of this hole being off, don't you presume, or wouldn't you assume, especially for a mechanic shop who's got these plates, or the new Fandangle X, that they're using this product over and over and over. They're putting the wrong product into the engine, and they're using equipment that is not properly setting it. And this, I mean, it's just, I can't be any more simple than this. It can't get any more simplified. It's just, it's what it is. I get DIYs calling me, and they have to question this stuff. But I get racing tech mechanics calling me, and they tell me, Tim, it's hard to understand how somebody like that can have that kind of stuff out there, and so many people are caught up in that. I don't understand it. You put out there the most simple way to do something, and if I had a wall here and it was black, and I had another wall here that was white, and Mr. Weeby said that this black wall was white and this white wall was black, because Mr. Weeby said it, is that reason to believe that that black wall is actually white? And that when Tim says, no, that wall is black and this one's white, that because Mr. Weeby said it, that I must be wrong. And it doesn't make sense to me. It never has. So that wall is black, this one's white. This product is wrong, and the self-guiding system is right. So we're going to show you up close here what happens to this thing. So here we have it. So we got this full body 5/8 tab. You can see it. You can even hear it. Now by the time you use this and you're on like the 15th hole, this thing's wobbling. So by the time you, and for mechanics who use it over and over, eventually this thing will be a ½ inch out of whack. How could that possibly guide it? Now you can't even see it. You're not looking at it. You're not paying attention to it. You're just assuming that this plate is actually holding this vertically straight. So we're going to push it from side to side. Now I'm going to tell you that this doesn't hold this thing straight. Are you going to turn around and tell me that it does? Are you going to tell me that that black wall is actually white and the white wall is actually black? Could it be that bad? Could the explanation of the simplicity of how this system works be that bad that you cannot understand that? Now, I'm not talking to the guys who do understand that, or the guys out there that are watching this video today who are going, you got to be kidding me, man. So what this is a marketing scam. This is a way to make money. And I'll explain that about us. We don't market on any of this. We basically sell this product we have to help those who need it. And the reason we do it is because of that. We don't do it to make money. Sure, we could go out there and make another jig for you. Don't TimeCert have a jig? Don't the other cert companies have jigs? They can't sue one another. It has nothing to do with that. There's no patent on this stuff. You've all seen the CCC versus Sure Grip studs on my site, and if you haven't, go there. Man, there's a video there that will explain why you don't use that product. But there's no patent on this stuff, so why wouldn't I make my own jig plate? Well, because it's not a necessary piece of equipment. And why would I want to take your money? I don't need your money. The studs that we sell is a very teeny, tiny thing that comes out of my shops. That's not what we're about. We're about the entire Cadillac. And we are a full-blown restoration company. And that's where I dwelled myself into, is restoration work. I do this because people need it. So now we just learned a lot there. Now we're going to move on. We're going to set this plate aside because it's an absolutely unnecessary thing. And we're going to talk about a little something else here. We're going to talk about what this post is all about. This post is about freehanding. So we're not sure who thinks that we're freehanding, because we've got videos out there that explain how this works. So we're going to talk about this piece of wood here. Let me make sure that you can see this piece of wood. Yeah, she's right there. Okay, so we're going to talk about this piece of wood. The reason we have this piece of wood here because we figure anybody who assumes that we're freehanding this stuff is about as smart as this block of wood. What's the name that you give somebody when they assume stuff? Oh, a blockhead. There we go. So, and we also know what the word assume means. So what we're going to do is we're going to talk about this. So if we were freehanding, what we would have is a piece of material that's like that. The most that we might be able to do to get started on this would maybe be able to take a hammer and a punch and punch a spot on that block so that our drill wouldn't take off all over it. Although that would be kind of taking that freehanding away, wouldn't it? So when we walk up to that solid piece of material and we take our drill, and I'm not going to drill into this, I'm just going to explain this. There's no guide. There's nothing to go on. Now they have guides for drills when you're drilling in wood, and they have flat surfaces so you can get nice vertical holes. But in a case like this, we're going to freehand. So I'm looking this way, man, and I'm going to try to balance it up and down like that, and then I'm going to go like this, and I'm going to try to get it back and forth like this, and then I'm going to try to do it like that, and then I'm going to take off that thing, man, and then I'm just going to drill a hole. And I'm so very good at it that I'm going to get that hole absolutely perfectly straight. You think? I don't. Because no one can freehand that hole and be as straight as the existing holes on that Northstar engine. So that is what we call freehand. So now we're going to talk about how we do this. This is a system. Now let's move the camera a little bit so you get a little bit better view going here. I'm alone today, so I'm your cameraman as well. So what we're going to do is we're going to get you over there by that block. Just like that. Okay, here we go. Here we go. Now what we've done, this is just a mock-up block because we need something to be able to show you today. So we've already removed these dowel pins and we've cleaned up the surface, and we're going to want to cover this. Say this was just a head gasket job and we didn't want to get any chips inside the engine. We're going to take some brake cleaner. This is all part of this system. So if you were doing a head gasket job on this block, this was out of your car, this is how easy and how simplified this is, and how fast you can do this. So what we're going to do here, we're just going to wipe this off so it's like residue free, so we can tape it off. But we're going to tape it off in a much more simple way. What we use here is we use a very thick clear packing tape. And this clear packing tape is made by Duck, and it's real easy to use, and it leaves basically nothing behind. And instead of using masking tape and running it over and over and over and over and over until we get to the top, and then we turn and we go down this way and down this way down this way, and we spend like 20 minutes masking that off, and because we're not wanting to let the holes come out and that. We're just gonna quickly go like this, and we're gonna do this like shingles on a house. So we just got one across the bottom, and then we overlap about 1/4 of an inch. It's too easy, I guess. So there's 3, and we're almost at the top. We're gonna put one here at the top. Put a little one here to cover that supports. And we'll put another little piece at the top here. So it's masked. Press that down good, a little bit there. There we go. Looking good. And I always have my pocket knife with me. So somebody mentioned, oh, you don't have to sit there and pull all those, punch each one of those holes out. That's kind of a drag. Well, between throwing that on in just a few, not even a minute, that's just a few seconds. Just walk over and I just take my knife very quickly. I take these holes out. I couldn't understand why that would be such a pain. How could that be a pain? Oh, the difficulty. There we are. So she's ready to drill at this point, and you see how fast that was. This makes for a really nice seal. It seals real good. It doesn't get waterlogged by when you're cleaning it, so because it's plastic, it's not a masking tape that will get wet and kind of stick, and you got to clean it all off. This leaves no adhesion residue behind, so when you pull this off, and you really want to pull it off, when you're done with the job, pull it off. Don't leave it on here overnight. You might have 1 or 2 spots, and then you might want to clean it off. In this case, this is all it is. So what we try to explain here is this is not a freehand operation. What this is a very simple guiding system. It's a self-guiding system. I'm going to pull you up a little bit closer here. And we're going to try to get this over there. Dial you in. Let's dial you right into the surface so you get a good view. Let's move you over just a little bit more. There we go. There we go. I think it's pretty good. What do you think? So what we have is we have a 1/2 inch bit and a 17/32 bit. The 1/2 inch bit we use because we don't want anything inside the hole to interfere with the 17/32 bit. And we always have a little oil. We like to use oil whenever we drill and tap. Don't let anybody tell you otherwise. So we're gonna show you real quick the simplicity of this and why it's straight. So we have a 1/2 inch bit that we've ground the tip off just a little bit, make a nice little flat surface to stop it at the bottom of the hole. Now you got this guide plate, you got these collars and things like that on this unnecessary kit that stop the drill bit. The reason for that is because it doesn't go to the proper depth in the block. The reason we grind the tips on our bits is so that we can take our drill bits all the way down to the very bottom of the hole. There's absolutely no reason for collars, no reason for a guide plate. Nothing. So at this point we're just going to show you. The reason that this happens is this 1/2 inch bit goes into what is already here. this is a 1/2 inch hole. So this was pre-drilled with a 1/2 inch hole. And down there in the bottom of that 1/2 inch hole is a set of threads. And what we want to do is we want to eliminate those threads in all these holes before we put the 17/32 bit in. The reason for that is so that when the 17/32 bit makes contact with those threads, it doesn't slow that drill bit down. We want that drill bit to self-guide to the bottom of the hole as it does on its own. That's its job. So we just get a little bit on the tip with some oil. You can see how that goes in the hole. The reason it goes in the hole is because that hole, you ready for this? You ready? Wait for it. It's a 1/2 inch hole. Amazing, isn't it? So this 1/2 inch bit is going in a 1/2 inch hole. So I'm not drilling that. I don't have to worry about going outside that wall. I'm not going to screw that hole up when that hole is already drilled at a 1/2 inch. All I'm going to do is let this go down. There it hit the threads, and then it's going to cut those threads very quickly. See it cutting them, and it touches the bottom. Now I just let it sit there, pull it inside a couple times, and that removes the chips to avoid wasting time having to use the air hose to blow it out. So there you have it. You have a 1/2 inch hole. It's still a 1/2 inch. The only thing that's different about this hole now is it no longer has threads in the bottom of it. The purpose for removing those threads is so that the 17/32 bit can be sucked to the bottom without interference and slow down when it makes contact with those threads. So we just simply go to each hole, let it go down, let it drill, pull all the chips out. No freehand here. Make sure you got a nice solid sound. Hear it? That means I'm at the bottom. So there was 3 holes that I just took those out of. I didn't have to put a bolt plate on. I didn't have to take the plate off and flip it around. I didn't have to put the bolts in. I didn't have to pull them out. I didn't have to flip it. I didn't have to turn it. I didn't have to bolt it. I didn't have to unbolt it. I didn't have to do one step at a time over and over and over and over and over. I just simply take my 1/2 inch bit, go through the whole system, I've taken them out. Self-guiding, no freehand. No freehand. Are you getting that? I'm almost there, and I'm just bare now. I really do this extreme. I just go through the whole thing real fast, but I'm going to try to go as slow as I can to try to bring it as simple as possible to those with the questions. It's amazing. All this time, there's been a misconception that Tim was freehanding the blocks. Now at this point, all the threads have been removed from the hole. There's no thread, no chips down in there, because I allowed the bit to pull them all out. So I would normally be rushing through this, want to call it that. It's just easy. Just seems like I'm going fast. But today, I'm just going as slow as I can to try to help you understand that there's no freehanding involved in this. Now we're going to move on to the next bit. These chips out from underneath my feet. Oh, by the way, these are some pretty nice curled chips. Just move these over here. So when my wife calls me in for lunch, I'm not carrying chips on my feet. So the next step we're going to switch bits. We are going to switch to the 17/30 seconds. So bear with me for just a moment. I'm doing this video all the way through for you so that you know there's no switch intermediate stuff going on here. You should also know that I don't like using a chuck key for my drill because I have no intentions of allowing my drill bit to come loose in the middle of my job. So I have a way of tightening it to assure that doesn't happen. Alright, so now you're all going, wow, there's no freehanding in that. Now the thing about this, you're going to say, well, isn't the 17/30 seconds bit a little bit bigger than the 1/2 inch, so now you're not going to have that hole? Yes, it is. It's the next size up, and it's a paper thin layer. And so the thing about the Northstar, let me explain this to you for a minute here, since it seems so hard to conceive. Aluminum is really extremely soft material, and so cutting the paper thin layer out of this hole with the 17/30 seconds causes the drill to speed drill itself to the bottom of this hole, and this hole becomes a self-guiding hole for this bit, and I'm going to show that to you, and it will keep it from going to any direction. Now I would have to probably get up on this table while somebody else pulled the trigger on this bit and put my boot right here and push this thing to the side to try to get this thing to cut out into the wall, because of its self-guiding properties here. Because of the soft aluminum, because it's only a paper thin layer, and this high quality, high speed bit will want to cut to the bottom of this hole as fast as it can. So what I do is just try to barely let it get started, and I can feel it get started, and it just instantly wants to pull. See that? It's pulling itself. I'm not doing anything. I'm just keeping it from turning, and it pulled itself where? To the bottom of the hole. I can look in that hole and see a perfect circle on the bottom, exactly in dead center. So you take this bit, you got to get it started just a little bit, and just let it go. Now you see this thing turning. That's because I'm trying not to grip it tight. I want it to do itself, do its look, watch. See there? That's what I'm trying to avoid. So I try to hold it by letting it do it, and you see my hand, I kind of just let it, go with it, because I don't want to bind it. I just want it to go on its own. That's my technique. So we go like this, let it get started. Look, it's going on its own. It sucked itself to the bottom. I didn't do nothing. It's not freehand. So the drilling, the misconception on the drilling, thinking that I freehanded this stuff, is actually pretty stupid. It's stupid, is what it is. There's no freehanding involved in this. Now, you get a close-up so you can understand what you're seeing here. Let's just do these 5 holes on the bottom for you as quick as we can. Now, people say, Tim, you've done thousands and thousands of these engines, or these holes. I don't want to exaggerate, take a lifetime to do thousands upon thousands, but we are well past the 1,000 mark. A couple thousand, maybe, yeah, even farther than that. But so what we got going here, but as far as holes concerned, thousands upon thousands. So now that you can see a little closer, you can see me just get a little bit of a grip. I'm going to allow the drill to suck itself in. Let's see how much of the drill you can see. I really got to get you to see this whole thing. Okay, you're not seeing the drill there, so let's kind of move it just a little bit. Pull it up just a hair. Get a real good view of that. Okay, there we go. So, again, I'm just, just barely holding the drill, just barely. But I got to keep it from twisting, so I'm gonna. You see my hand go with it a little bit? That's just because I'm loose. Look. I'm just letting the drill work. I didn't do nothing. It pulled itself to the bottom of the hole. All I do is just let it get started just a little bit. Look, there it goes. There it goes. There it goes. Look. Oh! Look at that! Self-guided itself to the bottom of the hole. Knuckleheads. There we go. Look at there. I just put it wherever I want. And no matter what I do or how I lean it, it straightens itself up and drives itself to the bottom of the hole. Isn't that amazing? Isn't that amazing? There it goes. Look, watch it now. Don't miss this. There it goes. Whoa! Yeah, look at that. Directly down the center. There it goes. Watch. Little bit. Look out. Yeah. Isn't that amazing? So, the misconception being told in an outright lie about how this is done and that I'm freehanding this stuff is a lie within itself. I'm not actually freehanding this stuff. It's an illusion to anybody that's watching. But as I slow it down for you today, I'm letting you know how this is done. This is not freehanding. This is a self-guiding system. I would assume if this block was cast iron that I wouldn't be making this video, but because it's an aluminum block, this is how it's done. So as you can see there, I was actually able, let's move you back so we can talk here. This was a self-guiding system to drill this thing. There's no freehanding involved. What it requires is that understanding of that. And the other thing that it requires is your basic tools that do the work for you. You have a drill, you have a tap wrench, you have 2 drill bits, and 2 taps. Now we're gonna show you tapping too. I'm not gonna leave you in blind there, although I've shown you quite a few times over the years here. So we can't get this in there too, because there was, in that derogatory post against my company, it was also mentioned that we are freehanding tapping. So what you see, the illusion that you perceive, and what we're actually doing are 2 different things. We are high-performance racing techs, and this is just something we do to try to help people. not market on this product because we're not making money off this product. It's just a very tiny, one of the many tiny things that we do. So the misconception on the Freehand is the type of tap we have. Now you seen, what was those words I seen on here? It says, doesn't matter what kind of threading tap you have, bottoming, tapered, or spiral flute. Okay. Well, we don't use any of those other ones that come in those other kits besides the plug tap. But we do use a tapered tap, which is explained and shown on the website. So what we're going to do here is we're going to just get this thing started. Now, here's something. We don't like to use a fixed tap wrench. To add to your make sure you can see this over here and I'm not out of the way. Not to add to your illusion or misconception on that other stuff, but this is, not only do you have to take that plate and flip it and move it and move it and flip it and flip it and bolt it and unbolt it and unbolt it and bolt it and flip it and flip it and bolt it and boot it, and then you're only here. And then from here you're thinking, oh my God, watching the clock, and you ever hear the clock start ticking? If you can hear it, it'll slow down on you. It goes tick, tick, tick. And while you're unbolting. And then you flip it. And then after all that agony, you also have a fixed wrench. Now if this is all you have, hey, that's fine. But these ratcheting taps, and you call me and I'll tell you exactly where you get this in your hometown and for how much. I won't speak about it on here, but this is patented for the company that owns it. Unlike the false patent on this product, this is actually patented. So we're gonna get started here. Put a little bit of oil on it. Now we've heard people say don't use oil. You're not supposed to use a self-tightening neckband either. But if you do, you might not use any oil. So use some oil. And we use that 1030 because it's all over the shop. And it works just as good. So we're going to get started. You think, well, how do you get that tapered tap straight, Tim? Well, when we're putting it in to get started, we kind of let it find its own way into the hole. And then we get it down just a couple of threads. Now, when this thing's going in straight, you can feel that it's going in straight because it doesn't have a lot of resistance. And you think, wow, that's really going down that hole straight. But regardless if it's going down there and straight, I just want to know it is, so I want to feel it. So I look at it from two different directions. One is from the long ways, and one is from straight up and down, this way. And so it looks pretty dadgum straight. Now I'm going to feel how it feels, and it feels real nice and easy. I don't feel any resistance. It guided itself. No resistance, no resistance. So what I do is I actually use a drill to do my tapping, but that's an absolute no-no. So you've seen that in other videos that I use a drill, and I'd like to use a drill now, but for the sake of showing you guys, I won't do that. So I do have not a guideline, but I'm so used to doing this, I know when that tap's supposed to stop. So I'm actually going to drive this down. Now imagine a fixed wrench, crank and crank and crank, but the tap and the tapping ratchet or a ratcheting tap, you just sit there and just go for it. Hey, I'm sorry. You guessed you should have. Let's have another gift. So I'm going to take this taper tap. I don't just pull it back out and put it back in, pull it back out. You take it down until I feel it resisting. And that's as far as I'm going to take it. So whether that was with my drill or with this guy, look at this. Isn't that amazing? Skipper, skipper. I won't bore you with all the holes. I'm just going to show you this one. So take that out, set it aside. Now we have chips in there at this point in time, so we're going to blow those out of there. That's simply blown out. We're going to switch to our spiral plug. Now you've seen that was all self-guiding. So far, there's been no freehand. This has been an absolute misconception, a deception on the part of the guy who's been slandering our company. So we're not going to slander in return, but we are going to explain that it was false information. Should be dealt with, but leave that to me, because I know when and where I'm going to do that. So hopefully it'll just all end and never have to worry about it. So we're going to take the plug tap down. We're going to use a ratcheting tap wrench. We're going to take it all the way down. Now I blew this chipped out once, but I'm not going to do it a second time until I'm finished with this. So I'm actually taking this down until it stops, and that's the end. So it's at the bottom of the hole. All right. Blow those chips out. At this point, I could see in the hole here, perfectly straight. There was no freehanding involved in this. So at this point, this hole is actually ready for a stud. We wouldn't normally stud at this point. The stud I'm going to put in it here, take back out. We like to use brake cleaner on it to get all the oil out. It's zero residue. I can clean really quick. And then at that point, we take a superior head stud, the strongest on the market. This stud is stronger than any other head stud for any other vehicle, and I think even stronger than our aviation counterparts, because we preheat treat before we cut. So normally you'd want to put some medium thread locker on here. Not that it's necessary, but most people like to feel comfortable. Now this, if I had the thread locker on, it'd work kind of like a lubricant to help get this in the hole. Although you can see it's going straight in without any problem. But to make it a quick operation and save you a day's worth of work, and make this job much, much more affordable and far more easier to accomplish, just take yourself a pair of pliers, or a pair of vice grips, put them on gently, and spin that thing straight into the hole. Now on these 399s, we just want to be down to the 4-inch mark. There it is, that's 4 inches. So 4 inches has got us to the proper depth, a very long distance away from the surface of the deck, which is an absolute, it's an absolute necessity that you do not stop this. At this point, this stud is pulling from deep within the block, giving it maximum clamping space. At least 50% from hole to hole is being sucked up tight to the head from its pulling depth. And if we were to take that stud and back that stud out, with every turn, the distance on the head that's being forced to the head comes in. With every turn, that space gets smaller. With every turn, it just keeps coming in closer and closer. using the smallest area possible for clamping force. So the more I pull it out, the more that just comes right in. So with every turn, that's what happens. So in the instructions for the incorrect studs, talks about making sure your threading is 1/16 of an inch below the deck surface to avoid having conflict with anything. Are you kidding me? Talk about conflict. You just did everything you could possibly think to do to go against all the engineering standards of head studs and how they're meant to be used and their sole purpose. So now I just raised the stud up to where it's 1/16 of an inch below the surface, and all that clamping space that I once had has been brought right down to just the area right around the hole. So when I'm pulling vertically on this, I'm just pulling from right here, right here. This does two things. It can distort the surface of the deck, it can crack, and it's pulling from in the water jacket in the wrong area, and it can crack your block. And we've replaced 6 engines to date with the wrong head studs in them with cracked blocks. So that should tell you something. Now we know we've had stories and people call us and tell us about their nightmare with them, and that their car is in the junkyard. They've given up. They don't even want a Cadillac anymore. And I certainly do not blame them. They always say, if only I would have known that your product was out there. Well, I put it out there, so you know I can only do so much. And when you have somebody telling absolute lies against you and your product on the market, it makes it difficult. So a lot of those people are people who fell for those deceiving lies and didn't know it till it was too late. So anyway, I hope you learned something here today. Our goal was to show you that the way you install head studs is a self-guiding system. It has absolutely nothing to do with freehand. We have allowed the existing holes to self-guide the bits into that hole to make a perfectly vertical hole. We did not come up to a block such as the piece of wood I showed you that had no holes, and without any kind of guide or jig or router base plate for the drill. We didn't walk up to this thing and just start punching holes in it and thinking that we were getting straight holes. We actually walked up to a block with an existing system, an existing engineering that was designed by the engineers who made this motor to pull deep within the block, giving us the opportunity to take a 1/2 inch bit, put it into a 1/2 inch hole, let it go down to the top of the threadings that were built up off the wall, not buried into the wall, and just take out that small coil spring of threads, giving us one clean hole from top to bottom. And that way we could take the 17/32 bit, allow it to catch itself, self-guide and self-drill itself to the bottom without my input, without my ability to get that thing off. I didn't stand on the block, I didn't shove the drill from side to side. I just allowed the drill to do what the drill does. And it pulled itself to the bottom, leaving the hole one paper thin layer larger, but absolutely perfectly straight. Then we took a tapered tap and a plug tap. We took a tapered tap that has a very, very, very long cone on it, and so it would be self-guiding, put it into the hole, allowed it to balance itself. We let it go down. I drilled it in just a little bit with my ratcheting tap wrench, but I still just did it for GP like I do on every engine I look at. I never assume everything is perfect, and although this was perfectly going into the block as always, I looked at it from this side, and I didn't look at it from over here. I looked at it from here. I could see that it was 90 degrees off of this, and when I looked down at this surface, I could see it was 90 degrees off that surface. And it guided itself. So we took that tap, we went down till it came snug, we pulled it out, we blew the chips out one time, we switched it with a plug tap that has a very small amount of threads on the bottom that help guide it. We put this into the existing threads that were already previously made, not freehanding, and allowed this bit to make its way down until the bottom of it touched the bottom. We pulled it back out the second time, blew the chips out only for the second time, and cleaned it with a brake cleaner, and it was ready for a head stud. So there you have it. There's the clearing up of the misconception that was put on the market, or the misconception that was put on the Cadillac forums, I must say, by Mr. Jake Wiebe and Northstar Performance. Again, your derogatory statements are not true, and it would be in our both best interest for you to market your own product, leave ours alone, and maybe even change your product to where it actually works on this Northstar. And I hope the best for everybody. No mudslinging, just absolutely defending our product and defending our system and how it's installed. The misconception is that we were freehanding. The actuality is we were never freehanding this. We just know how it's done. We're engineers and racing techs and mechanics, and we know what we're doing here. I hope this helps everybody who has this idea that that's what we were doing, and enjoy your project. Buy your product, you make your choice, buy your product, and install that stuff. It's pretty cool. Thanks for coming here again and hanging out with me for a little while. Here from CCC, signing out.